Hey, hello friends, welcome back to the channel. This is Aili Bhattacharya, your stats buddy, and today we are going to cover a very important topic which is least square linear equation. Okay, it is one of the most fundamental concepts in statistics and machine learning. I will walk you through the theory, the math, and how to find the line of best fit. So, yes, let's get started. First, let's start with what is linear regression. It is a way of to model the relationship between two variables, x the independent variable what we know and y the dependent variable what we want to predict. We assume the relationship is linear, meaning it can be described by a straight line, which is y is equals to a plus bx. Here a is the y-intercept and b is the slope. We call this our predicting formula. But in reality, our data points not fall perfectly in a straight line, right? So for each observation, we write small yi is equals to capital Yi plus ei. Here, capital Yi is the predicted value and ei is the error or residual, the difference between the actual and predicted values. What is our goal? Our goal is to minimize the sum of squared errors. So see, coming to the next slide, you can see S is equals to summation of EI square. Now, why squared? Because it penalizes larger errors more and avoids cancelling out the positive and negative errors. Okay. Now, see, S equals to summation EI square here summation ei square, and which again equals to summation of small minus capital yi whole squared is equals to summation yi minus a minus bxi whole squared. Here the constants, we want a and b to minimize s. To do that, we take the partial derivatives of s with respect to a and b and set them to 0. These are called the normal equations. As you can see here, so partial derivative of s with respect to a is equals to 0 and partial derivative of s with respect to b is equals to 0. Now, coming to the next slide, let's solve for a first. Some partial derivative of s divided by partial derivative of s with respect to a is equals to some minus 2 into summation of yi minus a minus bxi equals to 0. Now if we simplify it, we get summation of yi minus na minus b summation xi equals to 0. Now if we divide it by n, we get the summation of yi by n minus na by n, which is equals to a minus b summation xi by n. What is y? Summation yi by n? It is the mean of y, right? So y bar, and summation of xi divided by n, which is the mean of x, we write it as x bar. So we get the equation y bar minus a minus bx bar equals to 0. Then what is the value of a? A is equals to y bar minus bx bar. That is our first equation. The intercept depends on the slope and the means of x and y. Okay. Now coming to the next slide. Wait, yes. For b. Now we do this for b. See, partial derivative of s with respect to b is equals to minus 2 summation of yi minus a minus bxi whole into bxi, okay, is equals to 0. Now, if you substitute a is equals to y bar minus bx bar from the first equation which we have got from here, okay, if you do that, then we get summation of xi yi minus y bar minus bx bar summation of xi minus b summation of xi square is equals to 0. Now if you rearrange the terms, then we get b is equals to summation of xi yi minus, wait, coming to the slides. Yes, if you rearrange the terms, then we get summation of xi yi divided by n minus y bar into x bar whole divided by summation xi square divided by n minus x bar square, which is equals to b. See, if you can see the numerator, it is the covariance of x and y, the formula of covariance of x and y, and the denominator, the formula is of the variance of x. Okay, so basically the slope is covariance over variance. All right. Now, coming to an important note. There are actually two regression lines depending on what you are predicting. First, if you're predicting y on x, okay, then it means that you're predicting y from x, okay. The equation will be y minus y bar is equals to byx, x minus x bar. And if you're predicting x from y, then it means x on y, okay. Coming to the next slide. Yes, predicting x from y, then it means the equation will be x minus x bar is equals to bxy into y minus y bar. Here, what is byx and bxy? See, byx is equals to the regression coefficient of y on x, and bxy is equals to the regression coefficient of x on y. They are not the same. Alright? Why did I say this? See, what is the meaning of byx? Byx tells you for a 1 unit increase in x, how much does y change? And bxy tells you for a 1 unit increase in y, how much does x change? They measure the sensitivity of one variable to another. Okay? Now, that is a wrap up of the session. We have derived the least square linear equation step by step. To summarize, first we assumed a linear model. Then the next we minimize the sum of squared errors, and thirdly we solved for a and b using calculus, and number fourth is we intercept the slope and intercept in context. Okay, if you find this video helpful, give me a thumbs up, give this video a thumbs up, and subscribe for more mathematics and statistics content. Drop a comment below if you have any doubt. And yes, thanks for watching. We'll see you in the next one. Bye bye. Good luck in studying.